Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good
Good
morning,
morning.
sir.
Good morning, sir.
Good morning, everyone. Okay. So, what I remember was that in our previous class we have finished that probability problem. Is it right?
Yes, sir.
And we also obtained that probability.
Yes, sir.
Okay. So we are going to start with module 1 today. Okay. Without wasting much of our time, what we'll do is directly start with one of the problem, and with the problem I will explain what exactly is the concept.
So,
So
so,
yes,
so variance is nothing but the probability itself.
no. We have determined the 4 steps, is it right, in normal distribution
Yes,
problem?
sir. Yes, sir.
And what was the step 4 value?
0.9251.
Okay, so that itself is the final solution.
Okay.
That means what? There is a 92.51% chance. Okay. So this is about the last problem. Step 4. This was the last problem. We have obtained 92.51% as the problem, as the problem solution. That means what? It is nothing but 92.51% chance that the project will come. So what is the X value?
45.
45 days. Okay. Is it fine?
Yes, sir.
This is the required answer. Okay. All right. So next module, or this module is done. That is module. We're going to start with module 1. Module 1 was basically about uh, basically about manufacturing, how to manage different parameters in go into it, determine different parameters. It is also called about module 1. So let us assume that there is a mobile manufacturer. Okay. Now, can you just tell me what are the different raw materials required in order to manufacture a mobile?
Batteries.
Batteries,
Processors.
raw materials, battery, correct? Next, What else? What other raw materials required?
Processors.
Processors. Okay. So basically, we need some silicon board in order to manufacture this.
So charger can be required.
A charger can be required, but the basic raw material, batteries also cannot be one of the
Camera lenses.
lens, we can say. Okay. Charger can be accessories, etc. Is that right? Apart from that, raw material required. Okay. So similarly, this is one of the requirements. Similarly, labors. Correct. Labors required. One can for manufacturing, can be for packaging. So we require different type of labors. One can so different type of the units are required. Now, the availability of this can be different in different organizations. Some may be having this raw materials in abundant, is that right? And some may be having this raw material, complete raw material and labors in shortage. So the companies, if you have to see, they work under different constraints. And with the available raw material, available labor, and with the available budget, specifically the budget, they have to decide, or the program manager or the project manager has to decide what is the total amount of price that is going to be manufactured. Is it right? So it is not that every company will be having abundant amount of resources. Some can be called as a mid-sized organization. Some are called as small enterprises. Correct? Some are called as a large enterprise based on their total capital invested, total resources available. Correct? So n number of things. So based on these things, based on the total number of, the decision has to be taken as to total. What should be the total number of? What should be the total? Uh, decision must be taken by the project about total number of total number of correct. Everyone agrees to this.
Yes, sir.
Yes. This how about others? How about others? Do you agree with this? Based on the available raw material and based on the available number of laborers, the company or the project manager has to decide the number of products that are being manufactured. Agreed?
Yes, sir.
Yes, sir.
Correct. So this way, that is the main theme about this particular this particular module. Available resources, how we are going to balance all the resource, and that balance is nothing but it's called as the optimum use of the resources. Maybe it is the number of neighbors, number of resources. Correct. So how we are going to balance this in order to get the maximum out. So it is all about this. So even in sports, if you have to see, it is the same available amount of players, available coach, available team, and with available budget the team has got. The team has to decide as to what is the maximum output that they can take, total funds or total performance that can be generated. Similarly, with the different type of organizations, if you have usually in the manufacturing unit, these type of calculations process. So you may have come across with the ERPs, the supply chain systems. So basically, all these systems use such type of the programs wherein they decide the basic responsibility of the ERP, Enterprise Resource Program planning, correct? So resource planning. Basically, what the system do is the ERP's responsibility is to decide what optimum use of optimum number of resources that are to be used. Resources are nothing but raw materials, labor, so on. So one more example I can give. So possibly I have 100 rupees with me, is it right? And I know exactly that is mutual fund. Examples only are mutual fund and I have shares, or I have fixed deposits, right? Or I will make this as instead of 100 rupees, what I will do is I make it as 1 lakh rupees. This is the total savings I have currently. Now, there are three different alternatives. Alternate one, alternate two, the alternate fixed deposit, which gives 7%. Okay. There is shares which gives me 10%. There is mutual fund 15% annually. Okay. Returns. Now, how much am I going to invest on this? Correct. So I want to see that some amount is being equally. There are some type of requirements. Okay, from one side also. That is the amount I have should be equally balanced. Must not be invested. Must not be invested only on one investment. One investment. Similarly, so there are n number of constraints. I have put n number of, right? Out of which the first second constraint can tell me n. Is it right? Now, basically, I as an investor, I have to decide how much I'm going to invest in this. This. I cannot say that I'm going to completely invest on FD because it is only giving me 7%. I have 1 lakh rupees, but I do not want to completely invest on FD or fixed deposit because the returns is very much less. Right? Now, that is the reason I have put many of the constraints. Okay. So possibly next constraint can be the minimum amount in fixed deposit should be the minimum amount FD is equal to 10,000. So next constraint, because possibly I may be having a future goal as to maybe there may be n number of reason why I want AFP to be of 10,000 rupees minimum, correct? So these are the different type of the constraints. Now, how do I satisfy these constraints? Okay, how do I satisfy all these constraints and also see that I'm getting maximum profit out of this? Are you getting this? Any doubts? So in this, we are actually making utilizing the resource. Resource is nothing but the amount which I have, right? So with the available amount, how am I making maximum use of such type of the amount? So usually ERP, possibly you may be studying in your next year as to how ERPs actually work and what is their use. But ERPs makes a decision based on such type of the programs. Correct? Any doubts here? Or anyone wants me to explain this one thing?
So constraints, first point I didn't understand, sir.
Here, the first constraint is that there are three different options, right? First option is mutual fund. Second option is shares. Third option is fixed deposit. I have not still started investing, but I am just seeing which option is better. The mutual fund is better, shares is better, fixed deposit. So first constraint, what I put here is just to see that my money is safe. What I'm doing is I'm not investing my money only on fixed deposit. Why? Because if I invest my money only on fixed deposit, the problem is that it only gives me 7% interest annually. So if I'm investing 1 lakh rupees, I'm getting only some 7,000 or something. Right. So I want to see that it is not invested only. I am not investing complete 1 lakh into fixed deposit, but I'm having some share in mutual fund as well as shares. Are you getting this?
Yes, sir.
Correct. So this is the first constraint. Similarly, second constraint is I should have a minimum amount of 10,000 rupees in my FD. Minimum. It can be more than that, 10,000 rupees, but minimum can be 10,000. So one of the possibilities is that I put 10,000 in FD and remaining 45,000 in shares and 45,000 in mutual fund. That can be the second alternative. But I should know what is the good combination of investment. How much am I going to invest in shares and mutual fund? Correct? Is it right? Okay, any doubts? Or anyone wants me to explain this once again? This is the first example. Okay, if anyone has not asked any question, that means it is understood. Is it right?
Understood, sir.
Okay.
Understood, sir.
Okay. All right. So I'm going ahead then. All right. So we'll start with one example. Example one. Firm is manufacturing products. Able each unit of table requires 2 kgs of raw material, 4 hours of each share requires 2 kgs of raw material. and 3 hours labor. Okay, there is still the continuation of the problem. Just make note of. Okay, is it done?
Yes, sir.
Okay. So these are the different information given. The company is into manufacturing of table and chair. Okay. And the different resources required in order to manufacture this is uh, the raw materials which are being mentioned. Correct. So raw material is not being mentioned, but raw materials are required here in order to manufacture. Okay, so one of the constraint here is the company has or the manufacturing unit has only 60 kgs of raw material. So what can be the raw material in case of manufacturing of table and chair? in order to manufacture a table or chair, what resources are required here, or what raw material is required here?
So 2 kg for table and 3 kg for chair, sir.
Yes, correct. That's right. Yes, that's right. So in general, the raw material required for manufacturing a table or chair is wood. Is it right? Now, the total available raw material with the company is 60 kg. Okay, totally they have 60. Now, out of this 60 kgs, they have to plan how many tables and how many chairs can be manufactured. Similarly, total available labor hours is 96. So out of this 96 labor hours, the company has to decide as to what is the total number of table and chairs that can be. Okay, so that is basically the now we'll see how to do it. Okay, so the question is the question taken down.
Yes, sir.
Yes, sir.
So,
Okay,
so
yes.
is there any condition that both the tables, there must be equal number of chairs and tables here? Is there
There is
something like that?
no. There is no constraint like both the products have to be equally manufactured. Tables can be more than chairs or chairs can be more than tables. That is fine.
Yes,
Correct?
sir.
Okay. Let us assume that x1 units of tables are and x2 units of chairs are. So this assumption we have to do it for all the problems. We have to see that x1 and x2 are being considered in every problem. So what basically it says is we do not know exactly what is the total number of product A and product B that are to be manufactured. We are just considering it as x1 and x2. Okay, so it is given that the total available uh, raw material. So what is the total available raw material?
60 kgs.
And total available labor hours
96 hours.
hours. So out of this 60 kgs, now the company has to decide what is the total number of tables they can manufacture and what is the total number of chairs they can manufacture. Similarly, uh, with this 96 hours, the same decision has to be taken. Okay, what is product A and product B, number of product A and product B that is manufactured.
So, but labor are also given, right?
So with that given data, we have to determine what is the total number that can be manufactured, total number of tables and chairs. Correct? Is it right?
Yes, sir.
So any idea as to how to determine this? It's a simple mathematics. There is nothing much of. It is given that 60 kgs is the total raw material available. And with this, can we determine what is the total number of tables that can be manufactured? 60 kgs is the total raw material available. So with this, can we determine what is the total number of tables that can be manufactured?
Sir, if we split these 60 kgs equally to both the like for chairs and tables, then we can determine, right?
Yes, correct. So, all right. So, is it done? How is it done? So, have you made note of this?
Yes, sir.
Yes. Okay. Going for the next one. It is given that each table requires. So what is the total requirement for each table? Is raw material required?
2 kgs.
2 kgs raw material. Okay, and each chair requires how much?
3 kgs.
3 kgs. And total available raw material is
60 kgs.
60 kgs. Therefore, x1 number of table required 2x1 kgs raw material, and x2 number of chairs required how much?
3x2.
Correct. So total available is 60 kgs. And if the company is manufacturing x1 number of tables, then the total raw material is 2x1. And if the company is manufacturing x2 number of chairs, then it is x2 of raw material. Any doubts here? Anyone wants me to explain this once again? Anyone wants me to explain this once again? Anyone wants me to explain this once again? Is it understood here? How 2x1 and why 3x2? Okay, is it understood in that case?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Okay. Okay, so do you see any equations here? Can we formulate any equation?
2x1 plus 3x2 is equal to 60.
2x1 is the total raw material for tables. 3x2 is the total raw material for chairs. Both will be, if we add both, we'll get a equation. Okay, therefore, total raw material for chairs for tables is total. In examination, all this expression is not required. Directly, if you formulate the equation, that is sufficient. Total available raw material. Therefore, 2x1 plus 3x2 equal to 60 kgs. Anyone has any type of a doubt here? Or anyone wants me to explain this once again? Okay, so you can just write one statement. Total utilized raw material can be equal to or less than 60 kg. Why? Because it's not mandatory that the company uses complete 60 kg. Maybe less than that because in 58 kgs or 59 kgs, one complete table and chairs can be manufactured probably. 1 kg may be remaining. That possibility is there. Is it right? But this, whatever these table and chairs requirements are there, that requirement should not be above 60 kgs. Not go above 60 kgs. These consumption should not be above 60 kgs, but it can be less than or equal to. If it is less than or equal to, there is no problem. That's the reason we can write this equation as 2x1 plus 3x2 smaller than or equal to 60 kgs. You can number this as equation 1. Any doubts here?
What about the previous equation, sir?
Which one? This?
Yes, sir.
No, this is no more required. From here on, we are going to use this. That is the last equation we want. 2x1 plus 3x2 smaller than or equal to 60 kgs. Correct? Is it right? Any doubts here?
No, sir.
Why? Because sometimes there is possibility. Is it right? 1 kg of wood may be remaining uh, as a spare. Not mandatory that all the time complete consumption happens, but the consumption should not cross available raw material. Okay, so likewise, just formulate an equation for the labor hours. Those who have completed this, those who have understood this. Okay. Those who are writing this, done. Have you made note of this? Go ahead. Or anyone wants me to go back or explain anything? Any doubts here?
No, sir.
No, sir. No, sir.
All right. So in that case, right, equation on that. One table requires. So what is the total requirement here? Labor hours.
4 hours, 4 hours, and 3 hours.
One table requires
4 hours.
4 hours. Correct. 4 hours. And one chair requires
3 hours.
therefore, X1 table requires how much? How many hours?
4 hours.
4 into X1 number of tables. How many
For
hours?
X1.
For X1 hours. Is it right? So one table requires 4 hours. Let us assume that X1 was 10. Then how many hours would have been required?
10x1.
10x1.
No. One table requires 4 hours. Right? So similarly,
40.
yes, if you are manufacturing 10 tables, so what would be the total?
40 hours.
Plus 10 into 4, which is equal to 40. Same thing is happening here also. If we consider X1 as 10, then this would have been 4 into 10. Correct?
Yes, sir.
The same concept.
Sir.
We start with the graphical solution, you will correctly understand this problem solution. But since we are just in the starting mode of problem, first let me explanation. All right. So once it's done, therefore, two units of layers requires how many?
3x2.
3x2.
Yes. Hour. Okay, any doubts here? So what should be the equation?
4x1 plus 3x2 is equal to 96 hours.
4x1 plus 3x2
Is equal to 96 hours.
Even here also, it will be like labor hours can be used more or less, right? So
yes, less than or equal to.
Yeah.
Same thing holds good for the second equation also. Symbol will be smaller than or equal. Okay. Total available labor hours 96. I will directly write this as anyone has any doubts here? Okay. So this is basically the solution. Okay. So we have formulated two different equations. That itself is the solution. Right? One more equation we are supposed to form, that is for the profit. If that is formulated, our problem solution is over. So before finishing these two equations, I just wanted to know if there is any doubt.
So these equations are the answers, sir.
Correct. So with these equations, next we determine different parameters. Okay. That is the further discussion. But for this problem, the solution is achieved. We have already achieved the solution. Correct? So, fourth statement is that profit equation. It is given that one table is sold, profit how much, what is the profit earned by selling one table?
40 rupees.
Therefore, if x1 tables are sold, then total profit is equal to how much? One table, 40 rupees. X1 tables how much?
40x1.
Correct? 40x1. Similarly, the total profit by selling x2 chairs is equal to, if you sell x2 chairs, the total profit is equal to, okay, is it done?
Yes, sir.
Yes, sir.
Similarly, total profit How much?
35 x2.
Because we are selling all the this is the maximum profit that the organization can realize. Okay. So we'll just summarize all the three equations and we will write this in the next class. That is, right now the time is 10:54. Is that right? So we'll start at 11:50, 11:05. Start at 11:05 and we'll write a final summary for this problem.
Yes, sir.
So right now it is 10:53 and there are 12 more minutes. You can take that is 11:05. Start at 11:05.
Yes, sir.
Okay. And simultaneous, if you have any doubts, we'll discuss in the same slot. That is after 11:05. Thank you, everyone.
Yes. Thank you, sir.
Thank you, sir.
you, sir.
Okay, so good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So final solution is y. Okay, anyone wanted me to explain steps once again? Subject to subject to. What are the two equations? First one was
2x1 plus 3x2 less than or equal to 60 kgs.
from, and the next one was
4x1 plus 3x2 is less than or equal to 96 hours.
96 hours. This is about hours. One more equation is there. Thing where since the table and JS cannot be in negative numbers, is it right? So either it has to be zero. Number of tables manufactured can be either zero or positive number 1, 2, 3, 4, 5, 6, but it cannot be a negative number, right? So that is the reason this x1 and x2 value has to be greater than or equal to 0. Right? Any doubts here?
No, sir.
Okay. So this is the final required solution. Okay. So I hope everyone has taken down this. Okay. So I'm going for the next one.
So, in the
Yes.
last question, we don't need to solve the equation, sir.
We have to solve, but the question here is we have to only formulate the linear program problem. Linear program problem means what? We have to only determine the equation. That's it, which we have already done. Okay, so next, determining x1 and x2 value, we will see the next topic, how to determine.
Okay, sir.
So here, in this particular problems, what we are trying to do is there will be a research problem. Okay, not research problem. Sorry. This type of problem, what we are doing is there will be a management problem. Okay, management problem is always how to maximize the profit, how to maximize profit or minimize cost. Okay, so on and so forth. So these problems are now converted to mathematical equations. Okay, then that mathematical equation is nothing. Okay, is it right?
Yes, sir.
So here our concentration or focus is mainly as to how to convert the problem into mathematical equations. Once that is done, next step will be taken. Okay, I'm just going for the next screen. Example 2. For example 1, continue figure. Consider example 1. Suppose that each product, required to be packed now every unit of table requires 4 hours. 4 hours packaging, and each chair requires 3.5 hours for packaging. Okay, so total available packaging hours, is equal to 105 hours. Again, the same problem. Formulate the equation in this case. Okay, so any equation for this?
Four x1 plus 3.x2 less than or is equal to 105 years.
Same three equations we can write what we had written in our previous problem, and in addition to that, under constraints, we can write this equation. 4x1
Yes, sir.
4x1 plus 3 and 3.5x2 smaller than or equal to 105. Okay, so I'm going for the next screen. So what was the objective there? Profit. That is equal to how much? Previous problem, 30x1 plus 35x2. Subject to three constraints. What was the first constraint? For x1, is that right? What was the first constraint?
So first one is 2x1 plus 3x2,
All other than or equal to
60
kgs.
kgs.
Next,
4x1 plus 3x2 less than or equal to 96 hours.
correct. And the last one,
x1, x2 is greater than or equal to 0.
that will write it at towards the end. Before that, we want the third equation. What is the third equation? That is from this problem.
4x1 plus 3.5 x2 is equal to 105 hours.
So this is addition. This is the new equation added. Problem. 4x1 plus 3.5x2. All right, so is it done? This problem solution?
Yes, sir.
How about others?
Yes, sir.
Yes, sir.
Next problem, a bit lengthier. If you have understood, okay, easy to solve this. Okay, firm produces two products, A, B, and C. It uses two types of raw materials. One and two of is of which 5,000 and 7,000 respectively are viable. Okay, it's very important to note that this word is there. And whenever this word is there, that is available resource will be coming on the right hand side of the equation. Okay. So available resources will be coming on the right hand side of the equation. So just make note of this. We'll continue the problem in the next screen. Okay. So I'm going to the next screen. And environment.
So
Yes.
this is the part. This is a part of the question or
Yes.
solution.
No, this is part, or this is the continuation of the same.
Yes, sir.
This is the continuation of the problem. Question statement. Okay. First one is E. But once you get the solution, find it easy. The question statement is little lengthier. Can't help it. The entire labor force and manufacture 2,000. Anyone wants me to go back to the previous screen? Okay, shall I go to the next screen?
Yes, sir.
Can you do this? How about others?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So one last statement, last two statements. Minimum demand for each of three products is 600 and 500 units. Profit earned by each product are question is you have to formulate LPP. Okay. So any equations possible? So can anyone formulate any equation here?
So
Yes.
3x1 plus 5x2 is equal to 600.
3x1 plus 5x2 is equal to 600. See, the minimum demand itself is for product A is 600.
Yeah, the demand for the product.
Yes. Demand for the first product is 600. That is minimum.
Yes. Yes, sir.
So what should be the equation?
3x plus 5x1 plus 5x2 greater than or equal to 600.
Yes, but
So the minimum demand only we can take it as an equation, right?
yes, so we have to formulate a separate equation for minimum demand, separate equation
Profits.
for profit, and separate for labor for the raw material.
So here we are taking raw material as x1 and x2, right?
Correct. Not exactly X1 and X2. X1 and X2 is the total products produced. Just a minute. Let me start with the solution.
Yes, sir.
Wait until I start the solution. It went wrong here. Okay. Okay. All right. So first is screen is not working.